Dear students, in the previous class we have discussed forecasting from AR1 and shown that as the time horizon increases, forecast become the mean of the series and the forecast error variance become the variance of the series. Remember this, we are modeling a stationary stochastic process. Now we consider MA1 process. An MA1 process is yt is equal to mu plus epsilon t minus theta 1 epsilon t minus 1. So that yn is equal to mu plus epsilon n minus theta 1 epsilon n minus 1. And yn plus 1 is equal to mu plus epsilon n plus 1 minus theta 1 epsilon n. And y hat n plus 1 is equal to mu minus theta 1 epsilon n. We want to predict yn plus 1. We predict it as y hat n plus 1, that is mu minus theta 1 epsilon n, because epsilon n1 plus is unknown at the time of n. But to implement this scheme, we must know the value of epsilon n. And this requires knowledge of epsilon n minus 1, epsilon n minus 2, etc. epsilon 0. So what we do is, we set the epsilon 0 is equal to 0, so that the process starts off. And variance of epsilon n plus 1 is equal to sigma square. Variance of epsilon n plus 1. Epsilon 1 n plus 1 is the forecast error. The forecast error is, En plus 1 is the forecast error, and epsilon n plus 1 is En plus 1. So the variance of En plus 1 is the variance of epsilon n plus 1. Then yn plus 2 is equal to mu plus epsilon n plus 2 minus theta 1 epsilon n plus 1. Forecast it as y hat n plus 2 is equal to mu. Y hat n plus 2 is equal to mu. And if this is true for s greater than or equal to 2, and variance of En plus s is equal to 1 plus theta 1 square into sigma square is equal to sigma square y. And remember this, for an MA1 process, the mean of the process is mu. Variance is 1 plus theta 1 square. You just refresh what we have already studied. So as the forecast horizon increases, the forecast approaches mean mu. Forecast error variance approaches to the variance of the series. Variance of the series as forecast horizon increases. In the case of AR1, forecast approaches to mean. Forecast error variance approaches to variance of y. In the case of MA1 also, forecast approaches mu. Forecast error variance approaches to the variance of y. Now we consider ARIMA 1.1 process. ARIMA 1.1 process. Yt is equal to delta plus phi 1 yt minus 1 plus epsilon t minus theta 1 epsilon t minus 1. ARIMA 1.1 is equal to mu into 1 minus phi 1 plus phi 1 y t minus 1 plus epsilon t minus theta 1 epsilon t minus 1. And yn can be written as delta plus phi 1 y n minus 1 plus epsilon n minus theta 1 epsilon n minus 1. And that is right. And y t minus mu is equal to phi 1 y t minus 1 minus mu, something we have already derived, plus epsilon t minus theta 1 epsilon t minus 1. And y n minus mu is equal to phi 1 y n minus 1 minus mu plus epsilon n minus theta 1 epsilon n minus 1. And the minimum MSA forecast can be written as y hat n plus 1 minus mu is equal to phi 1 yn minus mu minus theta 1 epsilon n. That is, if you take expectation of this, you will get it as phi 1 yn minus mu minus theta 1 epsilon n. And it differs from the original, differs from AR1 by phi 1 theta 1. And forecast error variance is variance of En plus 1 is equal to sigma square. And for the second period, if you substitute the value, etc., y hat n plus 2 minus mu is equal to phi 1 square yn minus mu minus phi 1 theta 1 epsilon n. And as you can see, the forecast deviate from mean in a declining exponential manner. And the forecast error variance for the second period is variance of En plus 2 is equal to sigma square into 1 plus phi 1 minus theta 1 square. And if you extend this for nth period, y hat n plus s minus mu is equal to phi 1 raised to s yn minus mu minus phi 1 raised to s minus 1 theta 1 epsilon n. That is, the forecast tends to, this term approaches to 0, approaches to the mean, and variance of En plus forecast error variance is equal to sigma square into 1 minus 2 phi 1 theta 1 plus theta 1 square by 1 minus phi 1 square. The point is, for the ARIMA 1-1 process, the mean was mu. This was the variance. So the forecast error variance converges to the variance of the process. Forecast converges to the mean of the process. And as I have written this without deriving the steps, because this step the computer will calculate for you. What is important is, once you formulate a model, and if the model is correct, the forecast generated from the model will be minimum MSE forecast. And whether this is true or not depends on whether your specification is correct or not. If you have correctly specified a model, the forecast generated from it will be minimum MSE. And experiment with the different models, and you fix a model which is considered to be the best fit. That is, you have to fix models tentatively, then only you can reach the final model. So with this, our discussion of Box-Jenkins methodology or ARIMA modeling is complete.